And then share the things from my computer. Okay, dear students, this is the front page of my website, you know. This is the hyperlink to click to find what on the web page of the course. It is administered by me. Syllabus sheet, for instance. Okay. And then on the syllabus sheet, there is a program here, weekly program. In which week, what is the subject to study or to deal? Well, although in this table you see the chapter, it is titled Sheet Metal Work, okay, is the last topic, okay, in this table. From this table it is seen. But last week I received kind request, say from my elder students. They asked me, say, since during the summer practice internship, in the company they worked on sheet metal works, okay, and now they need to submit summer practice report. In the report, such works are to be explained, and at the appendix of the report, the necessary drawings, we say developments are needed, and then they should be able to create the model of such works, the objects. These are in the jargon called sheet metal work. But say last semester, since it was the last chapter, and because of Corona lockdown, the associated problems, I could only address that there is such a chapter, and then said that, okay, finding some books, read the chapter, and then try to learn it, but couldn't allow them to see the things in my lecture notes, because of Corona lockdown, started to use online education technique. In online education, teacher recorded things, and while the teacher explaining the things, projecting the slides from the lecture notes, okay, prepare audio visual videos, and then it is the common application, you know. Almost all the teachers use such a technique, and then allow the students to access to such a video record. But last semester, last year, I couldn't prepare. I couldn't find time, okay, to enable my students to study on sheet metal work. So after hearing that there is such a demand from my elder students, I decided to change the order. Instead of studying on this chapter to the end of the semester, probably using the last 2 hours of the semester, it is gonna be the subject of today. Yes, it is the decision, shift this topic from this time slot to this week. Okay, you know quite well, we finished the introduction chapter, and the chapter it is to review on sectioning and to see some complementary things, special etching rule, removed section, aligned section. And then in the order it would exist geometrical tolerance. But since I changed the order, okay, today the topic will be on sheet metal. Okay. In Metro class, in the content of the last week, yes, you found, of course, the online session records. It was a time last week on Monday, on Tuesday, sorry. And then, found this video record. It is about the sectional views of commonly used fasteners. These are pins, bolts, nuts, washers, solid washers. These are very well-known fasteners. Key also is a fastener. Okay. And well, there is one more item here. It says solid shafts. Yes, if you watch this video record, I am sure you have already watched this video record. It is true. Yes, at a part of the video record, teacher Murat Hoca talked about solid shafts and then the special hatching rule. It is to be satisfied while creating or drawing the sectional views of solid shafts. And then, well, focus the attention to aligned sections. To be able to understand aligned sections, you should be first informed on revolved views. This video record just introduces you what is revolved view and how a revolved view is drafted, and then explains the things on aligned sectional views. CAD application part. Well, I provided 3 video records. Well, aligned section creation in Inventor. Example 1 is relatively easier to deal, but example 2, in example 2, it is more difficult case. Okay, if you watch the video records, you can understand what is the difficulty. The difficulty comes from where. And then, well, after having the views in Inventor for that object, okay, well, editing is needed because Inventor for single components always creates the sectional views obeying to the general hatching rule. Although object has some features for which special hatching rule is valid, or although it is the object for which special hatching rule is valid or and also to be satisfied, Inventor, well, because of the coding, programming, say, can say mistake, or say little bit kindly insufficiency, can create the sectional views obeying to the general hatching rule. So, well, if it is the case, then we need to edit the view. Well, this video record is just to see one more time how such a sectional view is edited. Okay. In the content of last week, you found such things. So, well, while waiting for the arrival of the others today, your friend asked me just a few minutes ago, Hocam, how about tutorials? Beforehand, in the course policy, such a time slot to study will exist. How about this semester? Actually, I have already answered this question first meeting hour. Well, since I have my lecture notes in form of video records, okay, well, why not, instead of inviting you an online meeting, online session, and say that, okay, dear students, that is the video record, clicked on this hyperlink and then watch the video record. For instance, like this. Okay, I clicked on this and then YouTube environment and then watch the video all together. No, not necessary, because well, the video records are accessible and available. No need to watch the video records while in an online meeting under the control of Murat Hoca, under the control of Hoca. But say this is a a course. It has in catalog definition, you know, 4 contact hours. See the catalog definition one more time. Yes. ECTS credit 6. Well, you know, 2 plus 2, 4 contact hours. But, you know, since the course is a very crowded course and unfortunately the university senator couldn't discuss it is up-to-date content, and still some professors know that unfortunately engineering drawing is an issue today, even today. Well, the student using a pencil draw the projections, pen, paper, pencil drawing. Since they know as if it were the content, in the content it is the main tool, it is the main domain, say that, yeah, well, this credit is sufficient. They did know that we are using, very commonly used professional software, and the students how to be educated or learn the tools of such professional software. It requires extra time. And since the student should learn the things not only in the first quadrant, but also in the third quadrant, not to be informed on ISO standards, but also American standards. Well, the content is really, since 1989, it becomes getting more crowded, but unfortunately, decision makers, has no idea about such a content. So, well, it is kept still in this credit, 3 credits. But say in METRO, it is in our education method a strong recommendation. If a course has, for instance, like this one, 2 + 2, 4 contact hours, okay, would have to have in face-to-face education, then were student to determine the number of hours to allocate for studying on the content of such a course is to multiply this contact hours by 3. 4 times 3 makes 12 hours. But since the content is really crowded and there are lots of details, some of them tricky details, okay, for being informed or to study, well, my policy, I say that 4 + 2. 2 is just tutorial. Under tutorial title or recitation, I say that, okay, please, dear students, use 2 more. Let us have 2 more contact hours per week. So, well, 6 contact hours. If there were no video records, then I would kindly request you to be joined to such a complimentary meeting, tutorial meetings. Okay? Well, since there would be 6 contact hours, okay, obey to the recommendation, and 6 multiplied by 3, it makes 18 hours. It is the minimum number of hours to use for studying on the content of such a course. 18 hours per week minimum. Okay, of course, if you can find more hours, then this means you almost guaranteed to take a very high grade, letter grade, BA or AA. So, well, but since, here, this semester, well, we have the already recorded videos, audio-visual lecture notes. Well, instead of inviting you to tutorial meeting, I say that, okay, then at home study. I use asynchronous technique. For instance, at present, in the content of this week, well, these are in sequence, I started to count the video records, first day of the semester, record 1, and so on, 2, 3, 4. And then, well, in sequence, record 21. Record 22. Well, I highlighted writing such an brief info, say that this lecture note is from the content of MECH 113. Yes, actually here, after finishing the things about sheet metal work, okay, the topic of the next week will be on geometrical tolerances. To be able to understand the things while I'm explaining on geometrical tolerances, as I said at the first meeting time, yes, you should make a review on dimensioning format and the things to do in using the tools of software, how can show the dimensions in Inventor. And also, well, it is important a review is vital, important on size tolerances. Okay, to be able to understand the difference between size tolerance and geometrical tolerance, yes, your background on dimensioning and size tolerancing should be good enough, strong enough. Okay? Well, for instance, here, to be able to say that, okay, then you're ready to continue on the rest, I'm going to address those video records and say that study on those at home, not during an online meeting. Okay? Well, there are at present 4 video records. Well, I don't know, can use the other 2 hours or well, the tutorial hours where not in Cisco classroom, but at home. Find a suitable time and then watch this video records and study on them. Yes, asynchronous. But today, well, you're in the classroom and the meeting is online meeting. Okay. So, well, our topic is what? Our topic is sheet metal work. The title of the chapter is sheet metal. Okay, well, I'm going to drop the slides of my presentation. And on the slides, I'm going to deliver some complimentary sentences, explain the things. So, well, since I'm recording, then, well, in the end, there will be a video record as audio visual. Okay. This is the cover page of my presentation, sheet metal work. Yes, sheet metal work is a key phrase in the jargon. Okay? If you say that, what is that? Ah, yeah, it is a sheet metal work. Everybody understands the same thing. Of course, after studying on the content of such a chapter, you're going to be at such a level. And there is one more title on the cover page. It says development. What is development? I'm going to, of course, answer this question. Saying sheet metal work, we mean what? Saying development, we mean what? Yes, well, it is the time to find the answer of these questions and also thereafter the things, okay, to deal, to know, to do in Inventor. In Inventor, using which tools can create the model of a sheet metal work. Okay. Well, saying sheet metal work, well, directly give an example what we mean. In Inventor, well, this is the model of what? A sheet metal work. It is a sheet metal work. This object in general may be a part of an automobile, or this object may be the one to use at a part of an aircraft, the structure of an aircraft, whatever it is. But in general, it is called sheet metal work. In which case an object is called sheet metal work. If it is the case, well, say that during the manufacturing, first, from the market or stock, you found in the corresponding stock size a rectangular prismatic sheet. It is made of metal. Most common application, we use steel. Okay? Well, this is say that you found a rectangular prismatic sheet. Okay? And then take the sheet and then put these marks over the sheet. And then applying punching process, okay, create these empty spaces. Okay? And then using a press machine, okay, create this feature, punch it. And then, while using the bending tools, bending machine, fold the sheet. This is a sheet. By the way, when the such a rectangular prismatic object is called sheet, well, it is the measure see the thickness. Well, this thickness, if the thickness is less than 10 or maximum equal, say, maximum equal to 10 millimeters of cones, if the thickness of such a prismatic object, it is flat, it has flat surfaces at the beginning, initially, is less than 10, maximum equal to 10, then it is called sheet. If the thickness of such a simple right prism is greater than 10, then it is called slab. Well, measure the thickness of this one using the tool of inspection tool of inventor. I took a digital ruler and then indicate this H. You see it is 0.5 millimeters, less than 10. It is no doubt sheet. Okay? Since most of the cases the material is a metal, then say we generate the key phrase. We say sheet metal. If it is a sheet metal work, this means first in the market or from the stock of the company, we found, imagine it is initial shape. If you cannot, then we'll help you using this one, edit sheet. Well, first I should click on this button and then can allow you to see the initial shape. Yes, from the market you found a rectangular prismatic, say yes, sheet. Okay, take the rectangular prism. Okay, and on the prism, on the surface of such a flat sheet made of metal, common use metal is well, steel, and then, well, draw the necessary boundaries. For instance, here, draw a circle, draw this standard shape, using special pens, scribing the surface of the sheet metal, and also, well, mark this paths over the surface, this and the others, well, tilt it and then try to allow you to see the green lines. These are to be marked by the technicians, operators over the surface of this and that of the sheet. And then using the, say, folding machines, bending machines, obeying to the common practice and recommendations, fold this flat sheet. For creating such empty spaces, use punch press, special punching tools, cut the sheet, and then have such empty spaces. After the punching stage, after having such empty parts, okay, and embossing such a, say, feature, then it is in the order, it comes, well, bending folding stage. Fold this flat sheet along such predetermined paths, okay, to have this object. Okay, if the manufacturing technology, it is the thing, find a flat sheet and then fold it to be able to have such a 3D object. Then, well, in short, we say that it is a sheet metal work. Okay, the name of this object may be, for instance, just shield cover or just, I don't know, well, the name of this object. But in general, for any object, it has been manufactured in this manner, starting from a flat sheet and folding, just its shape has been set, finalized. It's called sheet metal work, my dear students. And Inventor is a very powerful software. Okay, just after finishing my lecturing part, I'm going to demonstrate how such a work can be created. Yes, you see we have along the ribbon, sheet metal ribbon, we have the tools, okay, for creating a flat part of the object, face, it corresponds to extrusion process. And for having such banded portions, flange tool, flanging tool, contour flange, cutting, for cutting purpose, this is the tool. It corresponds to extrusion to apply in cutting mode. Seaming facilities, punch tools, rip tool, unfold, refold tools, folding facility, bending facility, hemming facility. Okay, and then this powerful magical button to be able to see the flat form of such a sheet metal work. Clicked on this button and then see the initial form of the sheet metal work. And well, the technical drawing, not the views of such an object. Well, for instance, observe the object in which direction? This direction, say that this is the front view. Observe it in that direction, this is the left side view. Well, these are the views of cones on the engineering drawing sheet on the surface of the paper to provide. To inform the reader that it is final form, that is to be the geometry. Okay? But the valuable drawing for the interest of operators, technicians, is the development. Yes, the view of sheet metal work. It shows the sheet metal work as unfolded, and say using such an unfolded projection, unfolded figure, say a figure, the figure, it shows the object as unfolded. Well, technicians can see the shape to have on the surface of the sheet metal to scribe and necessary to punch. And then, well, draw this figure on the surface of the sheet, and then while using the bending machine, fold it to have such a final form. Okay. So, well, the projection of the object, it shows the object as unfolded. It's called in the jargon development. Okay. Well, if I create the projection of this object right now, it is, you see, unfolded. Then, well, in general, the corresponding image will be development. Yes, now turn back to my presentation. Yes, development means is the projection of a sheet metal work. It shows the object as unfolded. You can see on a development the unfolded appearance of the sheet metal work. Okay. A similar example in this slide of my lecture note. Well, in figure A, let's say A, we have the object to its pictorial figure. It is in the figure, it is just pictorial appearance. Okay. And the next figure, we have it is development. Okay, this is the valuable projection, actually, valuable drawing, because it is the drawing to scribe over the surface of a sheet metal, and then along those paths, while operators using the bending, folding tools of the company can fold the sheet and then set this form. Well, here, draw the attention to this transition part, or to that transition part. Okay, then, well, take a pencil, okay, using the annotation tool of Cisco. Well, this part, you see there is a round here, and along this edge there is a fillet. Well, never use in manufacturing the sheet metal works, we never bend them with very little rounding radius or filleting radius. Well, while you're taking the course second year 206, MECH 206, Strength of Materials, you can much more easily understand during the bending, okay, atomic bonding forces should be sufficiently large to balance the effect of applied forces. The forces are being applied, okay, by the tools of bending machine, okay. If we use very sharp edge in the design, then probably along the edge, the atomic bonding forces will reach to their limits, and then since it is impossible to have a greater tension within the material along the edge, then the material will lose its strength. Its strength won't be sufficient, and along the edge, it will tear, it will be split. To be able to prevent failure, to be able to prevent rupturing, splitting, yes, it is important. Well, especially in sheet metal works, in the design of sheet metal works, we use rounds and fillets. And another thing to pay attention, well, such an empty space is to be punched before the bending stage. Okay? If there were such empty spaces created via punching, then while this part is being bended, then, well, here at this sharp transition part from here to the rest of the object, it's a sharp transition. Geometry abruptly will change. And while we are trying to bend this part, then here and there will be tearings. Atomic bonding forces will tend to exceed the limit, and over there, the object will be damaged, will be teared. To be able to prevent possible tearings, to be able to make this part strong enough during the bending, yes, these empty spaces are needed. Okay, the difficulty comes from here. To be able to hold the sheet, okay, still keeping the material strong enough, object strong enough, well, what should be the bending radius? If the bending radius is equal to that much, then, well, such a fillet, such a round, if you unfold it, imagine that unfold like this, then yes, such a fillet or such a round corresponds to which area? Well, determine the area of the part. It corresponds to this bended portion. For instance, here, see this part. Well, there is an allowance actually, this part. What should be the size of this part on the development? Okay, on the unfold form of the sheet metal work. Well, what should be the size of this transition part to have to mark on the sheet, on the flat sheet? Actually, if you attempt to answer this question, writing some equations, then believe me, it is not so easy. Because you should need to consider the effect of bending. And while trying to bend the sheet, okay, along such an edge, well, some layers within the material will be under tension, some of the layers will be under compression, and the material will be first elastically deformed and then plastically deformed. During the deformation, the object, the metal, will change its shape and size. Well, considering the compression, the effect of compression and tension, and correspondingly plastic deformations, be able to determine the size of this transition part to mark over the flat sheet. Believe me, it is not an easy cake. It's a difficult issue. But today, thanks to the existence of the sub-programs in the structure of Inventor, it is really an easy case. Using the tool of Inventor, when we ask the development of the object, then, well, this area will be at the background automatically calculated by the software, and then the development will be created correspondingly. Actually, beforehand, to be able to reach to the level, okay, to determine the size of such transition parts, and also to be able to have the development of the sheet metal works in engineering curriculum, mechanical engineering curriculum, say there were two more complementary courses. Well, engineering drawing 1, engineering drawing 2, complementary courses, descriptive geometry 1, descriptive geometry 2. Well, it was a time I was a student like you. Well, I took not only 2 courses, 4 courses, okay? Just under saying engineering drawing. But the 2 more courses just subtitled descriptive geometry. Well, taking 2 more additional courses, well, might reach to the level thereafter to deal with sheet metal works. But today, thanks to the existence of, new generation software, one of them is Inventor, you know, SolidWorks, CATIA, etc. Well, to educate the students on sheet metal work, no need to use 2 additional courses in the curriculum. 1 year. First semester take descriptive geometry 1, second semester descriptive geometry 2. Instead of offering such 2 math courses today, we just use 2 hours. Okay? Well, first, using lecture time, introduces students saying sheet metal work we mean what, and then the next hour after the break, then give an example using the tools of Inventor. Although it is possible to finish the chapter in 2 hours, since I use spoon feeding method and never, especially for freshmen and sophomore students, never say that go to home and then find a book and study, learn by yourself, but keen on, explaining the things, demonstrate the things one by one in detail. Well, not 2 hours, but gonna use 3 hours for this chapter. Well, maximum, the time period, it corresponds to this week. Well, 2 hours, yes, now we are using the time, okay, already started, online meeting time, but the rest going to be in asynchronous manner, okay? If I cannot finish my demonstrations, especially on the CAD part, okay, by the end of the meeting of today, then yes, after you're leaving, I'm going to continue, record the video films in asynchronous manner, and then allow you to access to such recordings. Okay. Continue. By the way, I said 10 millimeters, but you see here it is to be corrected. The component having a thickness greater than 0, less than 12, it is called sheet. 12 is the threshold value. If the thickness is greater than 12 millimeters, then do not say sheet metal. You may say, depending on its shape, slab. Okay? Well, famous example, yeah? There is a box, for instance, tea bag box. Actually, why not? In my office right now on the table, I have such a thing. Well, yes. Okay, fold it. Well, the material, can you see? Okay, hide the registered mark of the company, otherwise it is going to be advertisement. Okay, then use the other side. Okay. Yeah, well, first, at the beginning, what is that? See, it is now a flat plane, flat object. Its surface is flat, and see it is boundaries. Okay, special in shape. But say this figure to have over the surface of the sheet is needed indent after the folding to have such an object. Now, when I am folding, assume, say that since it is made of carton, no need to use press machine or folding machine. Applying the forces, bending forces, using my thumb and finger, muscular force sufficient to bend them. Okay? What I am doing, I am folding. Fold this. Along this path, fold, 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 and then finally, what is that? It is a box, tea bag box. Okay? This is, well, although made of carton, cardboard, it is made of cardboard, but in the jargon speaking, say that it is a sheet metal work. This object is a sheet metal work. It is not made of metal. It is made of cardboard, but still say the same, can say the same thing. In general speaking, this box is a sheet metal work. Right now, you're using not laptop computer, but desktop computer. Well, see the case of the desktop computer. It is a sheet metal work. Well, the hood of an automobile, it's a sheet metal work. Well, the body of a refrigerator, it is made of sheet metal. Okay, it's a sheet metal work. In industry, it is a very common technology, sheet metal work technology. In the technology, first have the development, okay, as the necessary projection, and while using special pens over the sheet, draw the development, scribing the sheet surface, okay, and then using special cutting tools along the boundaries, cut the sheet, have this figure, and then the rest fold. Folding, you can have 3D object. Okay. Continue on the presentation. Yes. Here, of course, it is necessary to use such allowances. Well, existence of the allowances make the issue more difficult. For instance, well, to be able to have the box, okay, strong enough, well, okay, along this edge, fold, along this edge, fold, along this edge, fold. But you see, what is that? Laptop. There should be such a further extended part, okay? It is to be used for gluing purpose. This part is to be overlapped onto this part, and say if it is a cardboard object made of cardboard, then well, using paste of glue, okay, connect this part to the other. Okay, to be able to connect this part of the object to that part, then we need to use such allowances, such additional parts, such overlapping tabs. Okay, well, if we consider that these are needed, and also, well, if the thickness of the sheet is greater than a certain value, well, need to consider, for instance, here, extra space to have, it is required. Otherwise, while the bending radius might be very little, and along this edge, atomic bonding forces may lose their values, may lose their material may lose its strength, and then along the edge, we have lots of cracks, and then indent splitting. So, well, considering such allowances and lap extensions, well, be able to have this flattened figure. It is called, as I said, development. In inventory, it is not a problem, okay? It can calculate the area of such a transition part. And creating the development, it is considered and it is added. Another well-known example, you need to have a piece of tube or piece of pipe. How it can be manufactured? One method is deep drawing. The other method is sheet metal work. Okay, first start from here, considering the seam allowances. Okay, over a flat sheet, draw this figure in the necessary size, and then roll it using rolling special machine. Be able to roll it. Okay, it is illustrated here. Roll the sheet and then set it as final form. And then we'll be able to connect this edge to the other edge. Okay, furtherly folding along this edge, the sheet metal, it is called seam. Yes, seam allowance. Inventor calculate the corresponding area, and then when you ask the development can have such an allowance, okay, it is to have such a seaming. Another example, you need to have a hexagonal sheet metal work, which figure, and then this sheet metal work is to be closed at this end and at the other end. What should be the figure to have to draw over the sheet metal before bending stage, of course? Here is the answer. Well, these are, well, say, glue tabs for gluing additional extensions. Okay, and these are the pads along which the sheet metal is to be folded. Okay. Another example, it is a loft to have. Yes, well, what is the case in this example? Take a pencil. For instance, say that imagine it is an air conditioning system. We have a channel over here, rectangular prismatic. Well, preceding part of the system, we have another channel. But say the cross-section of the channel is to be decreased to be able to increase the speed of flow. If you decrease the cross-section, then the flow velocity increases. It is to be increased. Okay. Well, you see the geometry is changing from here to there, gradually decreasing. To be able to connect this part of the system to the rest, it is necessary to use such an adapter. If the object, such a part, in this example, is the one, it is cross-section in size changing from its beginning to the end, and or the geometry. Well, in this example, geometry is not changing. Only the size of the cross-section is gradually decreasing. But the most difficult case, not the size, but also the geometry is changing. For instance, preceding part is a rectangular prism, following part is a pipe, cylindrical in shape. So, well, the geometry will change from here to there gradually from rectangle to circular. Actually, in the content of MECH 113, giving an example, talking about loft process, I mentioned such things. But here, under the title sheet metal work, the loft is to be sheet metal loft. How it can be created? Well, for this example, the answer, say that this is the front view, this is the top view of the loft. Which figure is needed to use on the surface of the flat sheet, okay, at the end of the folding to have such an object? Here is the answer. Well, referring to this orthographic views and then applying revolve process. Okay, this is an intersection. To be able to have it as true length size, imagine that while you're holding the rest of the body, you're rotating this intersection. Yes, it is illustrated here with such a circle. Okay, imagine this intersection as if rotated in this direction. And then that intersection became parallel to the picture plane of this view. Then yes, well, orthographic projection with the figurative distortion, the length of this intersection is equal to that much. But after revolving stage, the true size image, true size value of this intersection is over there. This line is the revolved image. After the revolving stage, it is the image of this intersection. Using the revolved figures, the projections after the revolving stage, then draw the development. This is distance A2, A1. A1 is to be in true size. Drawing the development, it must be in true size. But from the projection given orthographic views cannot directly obtain the size of this feature, because by definition intersection A1 is an oblique line. Okay, well, one technique, axillary view. For this inclined trapezoidal surface, be able to create the axillary views. Okay, axillary view, and on the axillary view you can find the true size image for this boundary. Or the other technique, revolving. Okay, imagine such a revolving stage and make this oblique line parallel to the picture plane of this projection, and then over there see the true length size, and then transfer the value to the surface of the sheet through this boundary, and the others as well. Okay, I see that just having a look at the time of my monitor of my computer, well, sorry, it would be already break time. I have shifted the break time 5 minutes. Okay, now stop the recording for having a break, and then after the break continue on the rest. Well, first close annotator, and then can stop the record.